The interpretation of simulation results is not always easy, especially when dealing with large and complex piping systems. This is why we implemented what we call visual physics, allowing users to visualize multiple results directly on the schematic canvas. In particular, sensors are used in conjunction with the network result display to understand systems behavior at a glance. We'll start by looking at how we can add sensors to this branched water distribution network, and we'll zoom in on the pump, which will trip. In the system, network result display has already been enabled and is showing mass flow rate. When we hover over a link or node, we'll get a tooltip showing the value of the currently visualized result at that point. This will update as we run through the results and the value changes. To gain a deeper insight, we can add sensors to look at other results in addition to mass flow. To add a sensor, we click the Add Sensor button. This adds the sensor to the schematic, and then we can move it to where we require and connect it to the component that we require. In this case, the pump. We can then select the result we require along with a minimum and maximum range. The sensor will display as a label sensor with the numeric result. We're also going to connect a second sensor to display the speed using a dial meter. We connect it in the same way, then right-click to select the style. Once we've selected the style, we can resize and reposition as required. The feature displayed can also be changed from the right-click menu. We're also going to monitor the position of the check valve. To do this, we add a sensor as before, then connect it to the valve, selecting the valve lift, which will then display as a horizontal linear meter. The final result we'll display is the pressure at a node, which will be displayed as a vertical linear meter. As we then run through the simulation, we'll see the values on the meters updated as the pump trips, causing the valve to close and the pressure to drop. During the simulation, we can still use the tooltip sensor to monitor the mass flows at specific locations. In the second example, we're going to look at a storage system that has been pre-configured with sensors added. Storage tanks to the left and right of the model supply 2 receiver tanks in the center, which in turn are emptied by 2 consumers below. We've added a radial gauge to the pump and connected vertical linear meters to the storage tanks on the left of the model, and the 2 receiver tanks, which all show the level. We can also see the flow demand on the radial gauge. As the simulation progresses, we can see the level in the 2 receiver tanks dropping. When they reach a pre-configured set point, the pump starts, and we can see the level in the outer storage tanks dropping while the receiver tanks fill. And through this, the supply to the consumers is maintained. Once the receiver is topped up, the pump will be switched off again. So in conclusion, Simcenter Flomaster allows to simulate complex systems and to understand their behavior at a glance. Thank you for watching. For more information, please visit our website.